Tonight, thousands of worlds sit within reach of telescopes. Not one has answered. Where is everybody? In the next few minutes, meet the theory built to explain that silence, and the three prime suspects behind our solitude. Here's the strange part. The Milky Way is old enough that one slow-spreading civilization should have filled it many times over. The puzzle got its name in 1950 when physicist Enrico Fermi asked colleagues at lunch, "Where is everybody?" 11 years later, astronomer Frank Drake answered with math, an equation multiplying every factor needed for contact. Star formation rate, planet faction, habitable worlds, then life, intelligence, communication, and lifetime, 7 unknowns chained into a single number. Drake's 1961 calculation put the number between 1,000 and 100 million worlds. Still just a guess. 2 of Drake's blanks got filled. Kepler found 1 in 5 stars hosts a habitable planet. Across our galaxy, 6,000 confirmed worlds are just the beginning. If places like this pull at you, subscribe. If worlds are common and the math looks promising, why does every radio dish hear only silence? Something filters the numbers. In 1998, economist Robin Hanson named that filtering force the Great Filter, a barrier no civilization easily survives. His logic cuts both ways. The more common life turns out to be, the worse our own odds of surviving what's ahead. Hanson mapped 9 steps from raw chemistry to a galaxy-spanning civilization. Each step we've crossed leaves one less place to hide it. That leaves one question splitting scientists in two. Is the Great Filter safely behind us already, or still waiting ahead? What is the spark itself, abiogenesis, the leap from chemistry to the first self-copying molecule? On Earth, it happened fast. Within a few 100 million years of Earth cooling enough for oceans, simple life was thriving. That speed is suspicious. Fast beginnings might mean life's spark is common across the galaxy, or we can't see the failures elsewhere. Chemistry to bacteria was the easy part. Turning simple cells into complex ones took Earth almost 2 billion more years. Suspect 2 blames not biology but geography. The rare Earth hypothesis says complex life needs a long list of cosmic luck. A giant moon steadying our tilt, restless plate tectonics, Jupiter sweeping away debris, remove any one, and complexity may never arrive. Critics counter that thousands of new worlds keep landing in habitable zones. Maybe Earth's luck is ordinary, not rare at all. Suspect 3 isn't biology or geography, it's us. Intelligence may be common, but civilizations rarely survive their own technology. Rather than guess, scientists search directly, scanning atmospheres for biosignatures, listening for technosignatures no natural process could explain. In 2025, Webb found a possible biosignature on K218b, dimethyl sulfide, a gas linked to life. A NASA reanalyzation dropped the confidence to 2.7 sigma. A wider study reproduced it in barely 1 of 8 tries. Hunger for contact returned in 2017 when Oumuamua tumbled through our solar system, accelerating faster than gravity allowed. Comet 3I Atlas arrived in 2025. Telescopes heard nothing artificial, only ancient ice and dust. Here's the strange twist. Finding simple life nearby, on Mars or Europa, would be unsettling news. Proof the spark is easy. That would mean a harder wall waits ahead of every civilization. Our silence may not be empty. It may be the answer. New telescopes will test every suspect this decade. Subscribe to follow the evidence, one signal at a time.